Are we live? Okay, we're live. Okay, day 2. We are building a UFC Predictor app, and today we're gonna be using the new version of Opus 4.6, and also we will use newest codecs version 5.3. So it's gonna be fun. Today is a continuation of yesterday's stream where I initialized the project for UFC app, and I have created the databases, tables, and today we're gonna start with trying to populate the data. I need to populate the databases with the UFC fighters, statistics, all the necessary info, and yeah, I mean, today I'm gonna proceed with that. I will start planning with Claude. I'll start planning to understand how will I get the data. So yeah, let's go. What is this codex? Okay. Yeah, I'm gonna just browser tab. Let's run the application. And before I do that, actually, let's take a brief look at the project structure, the files. So is everything done? Okay, let's take a look. We have Prisma, scripts, source. We have app, main fighters. Okay, API, nothing is populated. We have just layout, and yeah, this simple home page. Okay, now let's get back to Claude. Hey, what's up, Claude? So today we're gonna proceed work on this project. I need you to take a look at your local MD file, and I have initialized the databases, created tables already. Now I need to proceed with the data. I need to populate the data of databases with the fighters and all the necessary information. We need all the information because it will be necessary in future for building the functionality of this app. So what do you suggest? How should we get the data? Should I search with your help for some sources that offer scraping, or maybe not scraping but getting them through API, or maybe we will scrape from some websites? Okay. What's this? Plan mode. I didn't switch to plan mode. Let's copy. Yeah. Okay, it does not delete like that. Okay, let's switch to plan mode. Okay, here we go. Okay, waiting for Claude. So UFC website has this data, which we will need. Total strikes, takedowns, okay. Significant strikes. I'm actually thinking to build the UI with a codex. Okay, so what's the plan? I think the plan is ready. Let's use the statistic fighters. Okay, let me check the link. What did it find? Okay, it found this page. Plan research UFC MMA data sources, fetch. Okay, fetch. How to fetch this content? Yes, let's go. Just thinking if it fetches all this content. Okay. Let's see how many token usage will be for fetching. Okay, web search, use the search scraping, Cheerio fighters. Okay, it wants to search. If scraping is available, Okay, so it even checks in GitHub to find some scrapers. Okay, you know, while it's doing its job, I guess I can just open another terminal and discuss maybe. Yeah, I have a couple of questions actually. Actually. Okay, so what do I want to ask? Okay, so can we build some algorithm or some function that when, so basically it will receive the data. Let's say for fighters, let's say there's a fight, UFC fight between two fighters, and you will receive the data for the fighters, their overall statistics, average strike per minute, and everything, like facing southpaws or wrestlers, everything. So I will try to provide as much data as possible, and I need this to give me the result, the prediction. So based on data, analyze this data really good and generate a realistical outcome. How do you see this happening? What will be necessary for this? Okay, so after eating a lot of tokens, actually it came with an answer. No free API has round statistics. For our database, its most valuable data in your schema and your stats. UFC.com is only free source. Okay, free APIs are incomplete. You already have a scaffold. Okay. 11,000 total requests across the fighters. It's a lot. 8 hours of unattended scraping at polite 2-3 seconds rate limit. Should we build scraper to the full historical scrape? So it's suggesting 8 hours to leave it unattended. Gives you complete data set for prediction models and fight history features. Okay, so actually I want to chat about this. Yeah, questions about scraping approach. Hey, Filmingo, what's up? No, man, I didn't publish. The real estate app. I just stopped streaming it. I was busy doing some other stuff and now got back, and yeah, vibe coding a new app actually, which is kind of interesting to me. So yeah, real estate, I did it. Okay, so what aspect of scraping approach are you concerned about? Rate limiting, getting blocked. Okay, so yeah, I'm concerned about the getting blocked part, but that's the least priority. The first question is, how will the process go? Will we build some automated functions that will run and just collect the data, or will you be managing this 8-hour process? I want to know if that's the case to consider the token usage, because 8 hours of your work, I can imagine how much tokens can you spend on it. Bill, can you imagine, like, you were I was streaming like real estate 8 months ago or something, and how much things changed since then. Like, everything became like fully automated since then. The coding is totally different. What is this researching? Okay, so it's designing the algorithm architecture. And also, by the way, on real estate, I stopped because like it's too much of real estates available from where I'm from. It's saturated. A lot of real estate websites like that is available, so publishing that, I just thought that it's a waste of time, so I decided to stop on it. Maybe I will proceed with some small problem solving applications or services, which is interesting actually. So great question and answer should put your mind at ease about tokens. I will not be running scraper. Here's how it actually works. I write scraper scripts, TypeScript files that contain only logic. Maybe 30-60 minutes of my time, so he'll be like 30 or 60 minutes coding these scripts. Really interesting. Why would it take so long? Okay, you run the script yourself. Once code is written, you just run npm run scrape fighters in your terminal. The script runs a standalone Node.js process on your machine. I'm not involved during the 8 hours. Script runs unattended. It prints progress of the console and handles everything automatically. Rate limiting retries database. You can literally walk away and come back when it's done. So it's suggesting me to walk away and just wait until it's finished. Okay, so the token usage is just for coding session where we build scraper. Is my other coding that actually or scraping cost 0? Okay. Yeah, I mean that's how it's supposed to be. Like you should just automate the functions that do it for you without any AI involved. Okay, regarding getting blocked, your stats fairly tolerance is public API. Yeah, I mean UFC is really public. There are many scrapers made for it. Yeah, AI in the process it just is not aware, I'm sure, of the token usage. Yeah, it's not aware. It's just knows the answer to the question if he will need to spend tokens on certain tasks. So yeah, my question was just he at the first, like Claude said that it will take 8 hours to scrape all the data, so I just wondered if Claude will be involved in the 8 hours of process of scraping. So if it would be involved, it would spend a lot of tokens, I guess, but it's not involved, so that's cool. Should the prediction... Okay, so now it's back to scope. Asking him should we scrape historical or start smaller. I think scrape everything full historical. Limits historical. Yeah, always backfill later. Or actually, I think recent 2-3 years would be cool just to see results. Because if it scrapes for 8 hours, I'm gonna go out and come back and see the result is not good. So yeah, I think 2-3 years for 2-hour work is good option, because I'm anyways going to leave for a couple of hours. Should the prediction function... Okay, so here what do we have planned? Prediction function works standalone. You pass the fighter stats directly as input, or should it work by loading data from Postgres? Okay. Both recommended. Core algorithm accepts raw stats object directly. Separate data loader pulls from DB. You can use either. Standalone, just the pure algorithm function. You pass in all the stats manually, no database dependency. Database only. Prediction function loads fighters data from Postgres. Via Prisma requires DB to set up with data. Actually, yeah, I need to understand the functionality of the UI first to answer that question, I guess. I mean, I don't understand the concept of both yet. If core algorithm accepts raw stats object directly, then why does it need separate data loader? Chat about this. Okay. Claude has written a plan. Let's see what's the plan. Oh, it's a big plan, I guess. So how scraper works. Okay, this I read already. Okay, plan is updated. What I'll build for helpers, rate limiter, HTML parser, in a mapper, progress tracker. That's cool. 3 scraper modules, events, fighters. Okay, fight round statistics. Nice. The 3 pipeline scripts, 1 master orchestrator. Okay, npm scripts that you can run. Cool. What you'll get 100 events, 800 fighters. Okay, starting from 2023. If it crashes, rerun and pick it up where it left. Okay, future proof. Same scripts can do full historical backfill, just remove date filter. Okay, that's cool. Ready to code. Data population plan, MMA fight companion. Okay. Database schema is created and empty. We need to populate it with recent UFC data. The project already has Axios and placeholder scraper targeting UFC. Okay. Approach scrape UFC stats, UFC official partner. It's the only free source with randomized stats matching your schema. No free APIs come close. Cool. Recent data. Okay. Alright, scraper. You run them in your terminal. Okay. Must follow this order due to foreign key dependencies. Events. Okay, first we need events. Scrape event list. Filter to. Okay. Then we scrape fighters. Extract fighter URLs from event cards. Fights. Post processing. Okay. Compute fighter with method breakdowns. Key difference from full scrape. Instead of scraping all 26 fighter list pages, we only scrape fighters who actually appear in recent events. This is more efficient. Okay. Us to create modify helpers, we will need rate limiter. That's cool. Parse. Yep, parse we will need. Mapper. Weight class. Win method. Progress. Okay. Scraper modules. Complete scrape fighter list. Yeah, for scraping fighters. Scrape fighter details. Field nickname. Okay. Scrape event list. Event details. Fight details. Fighters. Okay. Pipeline scripts. Scrape event list. Scrape each event detail page. Collect all fighters URL fight. Insert event records to DB. Takes fighter URL. Scrapes each fighter detail page. Okay. Yeah, it runs sequentially. Events, fighters, fights. Okay, just need to take a look at so it doesn't miss anything. Event details, event list, date, event link. Okay, so one question. Did you check that we are getting all the data from there? Because I didn't notice statistics like per fighter, total strikes done in career, out of them how many were significant strikes, total takedowns attempted. So like all-time stats, do we have it or it's not there? I know we have fight stats, but if we have total all-time stats for per fighter, do we have this? Yes, so you asked a couple of questions. Should the prediction function work standalone? Or you proposed both versions? So I want to try to understand what do you mean by it, like what will be the most optimal approach. I have not planned actually how the UI will function. Let's say when the user opens the card and there are two fighters, and it will be already maybe on the UI the prediction. So if it will be opened by opening the card, it means the function will receive arguments of the fighters, and maybe it will check in the database, because all info will be in the database. So what is the optimal approach? What do you think? And about the question, what level of prediction do you want? Actually, I need your input here. I want really good analysis. So should it be the algorithm which will analyze this based on the data, or for this to function better, AI is involved? So basically, should we feed this data to AI to analyze, or we can build the algorithm that will just do it with data provided? UFC stats provides career rates, not totals. It provides rates, so it doesn't provide how many strikes the fighter has. Yeah, we can get this data since we're scraping around where stats were verified. We can compute career, simple database query. Yeah, that's true actually. For how compute on the fly query round stats whenever career totals. Okay, add the normalized fields to the fighter model. Store pre-computed career totals. Yeah, actually, yeah, after scraping. Update them after scraping the. Okay, also I should scrape those career rate stats.
With Premium, you get to focus on the music. Explore a vast catalog of millions of songs without hearing ads. Or download your playlist.
Yeah, adding to fighter model is better version.
With the freedom to skip forward and backward as much as you'd like. Your audio, your control. Tap the banner to learn more.
Okay. Which prediction approach do you want to go with? Okay, so here we have on the input approach, given your UI flow, user opens fight card, sees two fighters, prediction appears. The optimal approach is fighters are already in your database. The API endpoint receives two fighter IDs, loads their stats from the database, runs prediction, returns result. The core algorithm tells the pure function, takes computed stats objects. This separation makes it testable and clean. So the database powered in production, but the algorithm itself doesn't touch the database directly. That loader, okay. On algorithm versus AI, this is a big decision. Okay, let's compare it. Your algorithm speed is much quicker than AI. Cost is free, AI is per prediction. Okay. Consistency, same input, same results every time. Different answers each time you ask. Is it correct though? If we are based on some logic, based on the data inputs, I think we should always get the same result. If it's not, there is some randomness there, so AI will tend to randomize, I guess. Transparency shows exactly why scoring breakdown. Okay, what's happening here? I just want to put this scraper so it goes and I can just continue with the algorithm. Okay, let's clear the context and auto accept. Let's go. So, consistency, same input. Okay, transparency shows you exactly why scoring breakdown. Black box or generic explanation. Okay. Offline works without internet, requires API connection. Very good with proper tuning, but purely statistical, can reason about context, camp changes, injury styles. So, yes, but will AI have this context like injuries and stuff like that? And so recommendation is pure algorithm for the core prediction because it's instant, predeterministic. It show the user exactly why fighter A is favored. Scoring breakdown is actually okay. It's interesting actually for algorithm. Okay, so it's a little bit interesting to me. First, let's touch the pure algorithm. How do you see this? Like, how will this algorithm count? Let's say you mentioned striking edge plus 12. What does it mean? So do you know how this algorithm will work? Like, let's say it will count that like one fighter has more strikes done and usually does more strikes. Will this will it be making decision based on this, or I want it to consider many factors actually, like it's not only strikes, right? We need to consider like deep level information, like the time of the round which has finished the fight. Like consider many things, like fighter tends to finish rounds at what time and at what type of fighter. So did you consider this in pure algorithm logic? And also you mentioned AI can not always give the same response. Why? Does it like randomize a bit? And also you said generic response. Also you mentioned the price of the AI. Is it like cheap version? Do you think I can like cheap version of AI can handle this prediction? Okay, let's go with this question. Where did my oh no, where did my prompt go? Okay, my prompt disappeared, did I say? Okay, is my prompt appearing? Okay. 1, 2, is my prompt appearing? Okay. I try to understand the pure algorithm logic. How will it work? Will it consider everything, like not only strikes? I don't want it to be like simple algorithm that looks at the strikes and says, oh, this fighter has more strikes, so he will win. I need to do deep analysis, like consider everything, not only strikes, but at what time fight finished, what type of fighter was the first fighter facing, and everything, you know, like deep analysis. So which one has the edge in this case, AI or pure algorithm? Because you mentioned AI will give brief, not very clear explanation of why it chose. So I prefer like strictly good analysis of data instead of like a generic randomizer of AI. Also, you mentioned that AI will cost like cents, and does it depend on a model of the AI? And do you think that cheap version of AI can handle this analysis? I need analysis to be predictions to be solid. Okay, so we get a response algorithm. I designed the analysis 6 major dimensions, which is a 4 or 5 sub-factors: striking, weight, not just who has more strikes, volume per minute, accuracy, defense. How will they? Oh, okay. AO power, target diversity. Okay, nice. Grappling. Physical attributes: reach advantage, height, age, form, last. Okay, experience, win rate, current, stylistic matchup. So okay. Opus top. Okay, yeah, Opus is the best one. Algorithm will, with AI isn't just cost. The problem with AI is it's what it doesn't have. It doesn't have a framework. It would look at the same data and say fighter A seems to have better striking without quantifying it. The algorithm gives you exact score striking. Okay. Yeah, I also think algorithm in this case is the best option. Okay, for now we can go with pure algorithm. I just wonder what's the usage here. Current session. Okay, cool. I mean, it's ate a lot of tokens actually. So it's creating pipeline scripts and updates. Okay, test compilation. Okay, clear context. What does it say? Okay, so it's a prediction engine that analyzes two fighters, compares statistics, produces realistic outcomes. Let's go deep, not just compare on, but analyze strike patterns, grappling. Okay, pure weighted multi-factor algorithm, no AI, pure instant read. Okay, all new files under lay predictions. Okay, now scoring functions. Each scorer profile, fighter profile, number. Okay, so it is considered control time. That's what I wanted to ask. Control time is considered. Ground striking, relative scorer. Actually, I will need also a nice description of why this is not only the result. But I can do it later, I guess. Not to overwhelm it too much information. Let it build the algorithm first. No, it's mentioned like dimension breakdown, so maybe there will be some generated description. Edge cases, few fights, fall back to career record. Okay, that's actually bad edge case, but no, few fights, 0.2. Missing physical data, neutral score, long layoff. I just wonder how does it handle these edge cases and has so much understanding of the this algorithm. I just keeps I'm thinking that it has worked on such thing already. As if it has built already such stuff. I guess it has. So Claude has written a plan. Yes, clear context, proceed. Yes, proceed. Yeah, I noticed it has issues with starting the Prisma all the time. Like yesterday, it was giving me the same error. I think I know why. That's crazy. I didn't start the server. Okay, helpers work perfectly. Okay, so it's finished. Everything is implemented, compiling cleanly. Here's some of what I've done. I added 8 career rate stat fields. Okay, is nullable floats. Added 10 career total fields. Push schema to database successfully. We have helper modules for scrappers. Scrapper modules, pipeline scripts. Okay, cool. npm scripts added. Events. Okay, full pipeline, 2 hours. Okay, so all we have to do is run the scraping pipeline. I guess I run this to scrape everything. It will take, it says, from 1.5 to 2 hours. Runs unattended. Okay, that's cool. All face are resumable, save to stop and rerun. Nice. Okay, let's go. Let's run directly all. Okay, scrape. Let's go. Cool. I'm expecting immediate error on this. Okay. Okay, that's cool. I don't know. I guess I have to wait until it finishes the algorithm. Then we can proceed, I guess. Okay, so what's happening? I see it finished the algorithm, or okay, so fight companion. Okay, npx tsf, let's go run the build. Okay, so we have some result here. Okay, build compiles with 0 errors. Let me verify all files searched. Okay, all files created, TypeScript. Okay. Computation, file scoring dimension, cool. API key design decision. Deterministic, pure math, no randomness or AI calls. Okay, cool. Okay. Yeah. Oh, okay. Please commit, and also consider that I implemented with the second Claude terminal data scraping functions. So for you to be aware. So when you commit, just in the message write that you implemented algorithm and also implemented data scraping functions. Okay. Okay. Implemented the weightlifting. Yes, proceed. Yeah, it has a bit ego because it's always living in commits that co-authored by Claude, you know. Committed 30 files. Okay, covered both. Okay, let's check the usage after that. Usage. Okay, 27 used. Actually, it did a lot for the 27% is used for the current session, and it did a lot actually for this 27%. Okay, so okay, it found 1,500 URLs to process. Cool. Okay, so we have the algorithm. I want to test it, but yeah, we don't have any data for me to test it right now, but let's just take a look. We have components, API route. What is this route? We have the SOD validator. Compute metrics. Okay, so let's take a look at experience scoring. Scores a fighter's experience in record 0 to 100 scale. Okay. Win rate, fight count, current streak, ranking. Okay, so it takes the total fights, win rate score. Fight count. Current streak. Activity ring rust. It's funny that it's considering this. Turn clamp weight average. Where is this weighted average coming from? Good metrics. So this function scores experience. Okay, cool. This experience notes generates human readable notes. Okay.
Want to spice up your listening? Smart Shuffle can weave
A stronger win rate.
for your playlist when you join Spotify Premium. Or start a jam where you can invite your friends to create and add to shared playlists, all with unlimited skips and repeats. Tap the banner to learn more.
Hey yo. No one. Yeah. The token usage is actually a lot on this Opus 6. But I gave it a really hard prompt, so I'm not sure yet. How is the usage? It's 8 pretty plenty amount for generating some scripts, web scraping scripts, and the algorithm for algorithm. I think it took like 40 to 50k tokens. So yeah, pretty cool usage. I'm not that experienced with Claude yet, so I don't know how you would take him before, but let's check the usage here. And it says, yeah, I mean, still the same 27% for the current session. It's pretty cool. Okay, so experience notes. Okay, so experience notes, we have, yeah, just the human readable notes is generated. Streaks. Okay, that's cool. Has lost in a row. That's cool information. Just for pure algorithm without AI, it's cool to generate such stuff. Computes inactivity penalty as a multiplier. Okay, and then like after everything is implemented, I just need to come here and adjust maybe these numbers for more precise predictions. Actually, I'll compare. There are some AI generated predictions. I just want to compare this algorithm to them, the outcome, how will it check. I just don't want this to be like shallow, like for example, you have the odds from the bookmakers for the fights, and the bookmakers of course have the background of the fighters, and they give logical odds. And if this algorithm works like that, that it's also like always tending towards the lower odds every time, it means it's not working good. So yeah, it will be cool to test this. So compute streak score. What is this? Diminishing returns, 1 win, 5-5. Okay, so it checks if it has the win streak. Clamp 50 plus win streak. I wonder where it gets these numbers from. 8. Why 8 specifically? I need to check this later. If lose streak, return. Okay. Coming off draw. Okay. Yes. Is Opus 4.6 good? Yes, it seems really nice. I have not yet bumped into some problem which Opus cannot solve, and Opus 4.6, I just started testing it like an hour ago, and it looks really cool. But yeah, I mean, it's doing its job for now. I had to test it today, continue testing it. So it has some features which I have not used, and for now I think on this stage I don't need it. Maybe later. It has features like, one of the features which I want to like check is like team. It can create team of tech lead and some workers that can like delegate the task and communicate between each other. That sounds really crazy. Communicate between each other on some task and update each other on the progress. Maybe it will be them testing or whatever. And tech lead like use the orders, see the orchestrates. Yeah, it sounds really cool. Let's see. Later I will definitely do it. I yet need to discover some skills, how skills work. I think as the project goes, I will definitely use it. And I downloaded one skill from Claude. It was skill or plugin, I don't remember, but it was a front-end skill, and I think I will use it to develop UI. But I also want to test on the Codex 5.3. The UI, they say it's Codex UI is much better. So let's see. Yeah, I think I'll be doing it today, later, maybe in a couple of hours. I need to go out. Maybe I will leave the stream. This is anyway, Scraper is running, so yeah, once back we'll have the full info in the database and we'll be able to test algorithms. It sounds really exciting. Yeah. Hey, what is this number, I wonder? Let's check this function. Normalize big one. Normalize stat against a league average. 0 to 100 scale, 50 league average. Sensitivity 1. Okay, so by default it's 1.0. Okay, so it measures this on takedowns landed 1.2 and takedown. What is this? acceleration score. Takedown defense. So does it mean it prioritizes this function more? How well is that? I think yeah. Takedown defense score is higher, I think. Okay, so we have the algorithm ready, yet we need to test it. What else can we do now until this scraping finishes? Okay, so guys, I'm gonna leave. I'm gonna come back in a couple of hours while this is being scraped, and then I'm gonna continue. So yeah, thanks for watching.